Alrighty guys, so today we are talking about colligative properties. Okay, colligative properties can include the boiling point, I guess I should say what they actually are. Colligative properties are the aspects of solutions that can change with the amount of solute added. Okay, so we have a liquid, say. We'll do that. We have a liquid, and it is a pure liquid. Okay, it's just that compound. Let's say this compound is water. Look at that. We have a glass of water here. Its colligative properties include its boiling point, its freezing point, and the osmosis pressure. Okay, I'm sure you guys have heard of the first two. The last one, maybe not. But the boiling point of water is 100 degrees Celsius. Okay, pure water, 100 degrees Celsius. Freezing point of water, 0 degrees Celsius. Okay, and the osmosis pressure, it depends on the situation. Depends. But the boiling point and the freezing point, they are exact at 100 degrees Celsius and 0 degrees Celsius. Now, these colligative properties depend on the, let's see, let's do green. These properties depend on, on the chemical, or we'll say the molecule to molecule interaction. Okay, this is also known as intermolecular interactions or forces. Okay, so based on these like molecule to molecule interactions, the whole, let's say, water has a boiling point of 100 degrees Celsius and a freezing point of 0 degrees Celsius based on their its intermolecular interactions. Okay, now when you add a solute, this interrupts those interactions. Okay, and so what tends to happen is when a solute is added to, say, water, the boiling point increases, the freezing point decreases, and the osmotic pressure increases. Okay, so this, let's say the solute, without anything in there, has a certain boiling point and it has a certain freezing point, and depending on the situation, it has a certain osmotic pressure. Okay, now we add salt to it. Okay, the whole reason that we add salt to pasta and salt to frozen roads, okay, the boiling point, we want water to get hotter before it starts to boil, and so we add salt so that the temperature of the water, because normally let's say we have that water and it's just plain water, there's no salt, okay, it's going to increase up to 100 degrees Celsius, and then it will boil and it won't get any hotter. Okay, it will stay at 100 degrees Celsius until it is all gone into gas. Then we add salt, and we have a container that maybe can get up to 110 degrees Celsius instead of just 100 degrees Celsius. Okay, and so that pasta will cook faster and all that jazz, and then it'll end up being flavored at the end. The freezing point, we have the road, okay, and there's ice on it. Okay, ice is somewhere, maybe it'll be at like negative 10 degrees Celsius. Okay, that ice is at negative 10 degrees Celsius, and it is just water. Then we add salt, and we have our road, and it is now puddles of liquid water that is at negative 10 degrees Celsius. Okay, so it lowers the freezing point, from, say, 0 degrees Celsius to like negative 15, so that that ice that is at negative 10 is no longer ice. It is now liquid at negative 10 degrees Celsius. Okay, and now we don't have to worry about slip sliding on the roads. That is the whole reason we put salt on the roads. Now, osmotic pressure is a little bit different. It's more based in biology. So we have a container, and it contains water, and then there is a membrane down the middle. Okay, it's not completely like, it's not like a wall. It's a membrane that allows some things through and some things not. So right now there is no salt in there. Then we can add some salt to the left side. Now the osmotic pressure is the pressure that is keeping water molecules from traveling through the membrane to the other side. Once that salt is in there, they really want to get over to the salt so that they can even out the concentration between both sides. Okay, so what it wants to do is it wants to travel from the left to the right, and so the concentration of the salt is diluted. Okay, The osmotic pressure is the pressure required to keep that water on the left side. And so if the water molecule really wants to get over to the right, then you're going to have to push harder on that water molecule to keep it over to the left. And so that is an increased pressure on the left side of the container. Okay, that's what osmotic pressure is. It's more based in biology, depending, like if you get dehydrated, then you have an increased amount of like salt in your in like your blood and your not amount of salt. You have an increased concentration of salt in your blood and your cells, and so water really wants to get into those cells, and so the osmotic pressure would increase to keep the water out. Okay, so that is all for today. Let me check my notes. Yes, so I will add one more thing. We'll talk about the actual calculation next week for this, but the salt that you add is important. So on the roads, we don't add table salt to the roads because table salt only breaks up into Na plus and Cl minus. Okay, that is only 2 ions. So to be more effective, we actually add, some places add calcium chloride. And so calcium chloride will break up into Ca2 plus and 2 Cl minuses. That is a total of 3 ions, and the amount of ions added to your solution, so the amount of ions you add to your water when you're boiling, or the road when you're trying to lower the freezing point, the more effect that these ions have on these colligative properties. Okay, so this would say increase. These are just arbitrary numbers I'm coming off with at the top of the dome. The boiling point would increase from 100 degrees Celsius to like 110 maybe for NaCl, but then for CaCl2 it would increase from like 100 degrees Celsius to 115 degrees Celsius. Okay, so the more ions that you're adding, the higher the Van Hoff factor, the larger the impact is going to be on the colligative properties. Okay, that's where I'm going to leave you guys today. If you have questions, make sure you're asking them, looking them up yourselves as well, if you have the time. And that will call it for today. Stay healthy and make sure that you guys are getting enough outdoors breaths. Don't go outdoors, but like open a window and breathe in the outdoors.